Today we will learn how to determine degrees of freedom of a plane mechanism. Plane mechanism means two-dimensional mechanism. So for this purpose we use Gruebler's criteria. What is that? That we will learn today. Say a mechanism has n number of links. So number of links So when we are making mechanism from this n links, then one of the links must be fixed. One link is fixed. So number of movable links will be equals to n minus 1. Now each link being on a plane will have 3 degrees of freedom. Any rigid body in space can have 6 degrees of freedom. 3 translation along 3 mutually perpendicular axes, that is translation along x-axis, translation along y-axis, translation along z-axis. Also there will be 3 rotations along x, y, z, that is rot x, rot y, rot z. But if we consider only two-dimensional links, that means links that will be on a single plane, in that case it can have only 3 degrees of freedom. How? That I am trying to demonstrate. Let's consider this to be one link. Okay. Now I am considering 3 mutually perpendicular axes. X-axis, y-axis and this is z-axis. Now if we consider this to be one link, then being on the plane, it can either translate along x-axis or it can translate along y-axis and it can rotate about z-axis. But if it tries to translate along z-axis, then what will happen? Then it will move like this. That means it will be out of the plane. So it will be no more on the plane. Similarly, if it tries to rotate about x-axis, then also what will happen? It will be again out of the plane if it tries to rotate about x-axis. Also, if it tries to rotate about y-axis, in that case also it will be out of the plane. That means it can have 3 degrees of freedom: translation along x, translation along x, translation along y and rotation about z. So previously we have seen that if a mechanism is made of n links, in that case number of movable links will be n minus 1. This is number of movable links. So degrees of freedom, if we write it as f, then f will be equals to 3 into n minus 1. But we must subtract the restraints. Restraints means whenever we will make one mechanism, then we must pair the links. So whenever we will pair the links, some of the degrees of freedom will be arrested. So those degrees of freedom which will not be allowed, that must be subtracted from this. So we must subtract number of restraints. Restraints means what? Restraints means arrested degrees of freedom that are not allowed. Now, if we consider a pair which has single degree of freedom, in that case number of restraint for that pair will be 2, because there can be maximum 3 degrees of freedom. So single degree of freedom pair means it will have 1 degree of freedom and 2 restraints. So if there are p1 number of such pairs, in that case total number of restraint will be 2 into p1, where what is p1? p1 means it is pair with single degree of freedom. If a pair has single degree of freedom, that means there are 2 restraints. So if there are p1 such pairs, in that case number of restraints, total number of restraints will be 2 into p1, which must be subtracted from 3 into n minus 1. Again, if we get a pair which has 2 degrees of freedom, in that case number of restraint for that pair will be 1. So if there are p2 such pair which has 2 degrees of freedom, then we must subtract 1 into p2. Here what is 1? 1 is the number of restraint per pair, and as there are p2 such pair, so 1 into p2 will be number of restraints imposed. So what is p2 then? p2 is the pair with 2 degree of freedom. DOP means degree of freedom. So p2 is the number of pairs with 2 degree of freedom. Similarly, p1 is the number of pairs with single degree of freedom. This relationship is known as Gruebler's criteria. Now, with one example, I am showing how to calculate degrees of freedom using this Gruebler's criteria. I am taking one 4-link mechanism. One link, 2 link, 3 link, 4 link. Now I am fixing one of the links. So I am fixing this one. Okay. So now I'll try to calculate the degrees of freedom of this mechanism. So here in place of n, what should I write? I should write 4. N is equals to 4 in this case. And what about this P1? P1 is the number of pairs with single degree of freedom. Now you see this pair has only 1 degree of freedom. So this is one single degree of freedom pair. This is also another single degree of freedom pair. This one is also single degree of freedom pair, and this is also single degree of freedom pair. Because this joint, the relative motion possible, that is only 1. That is relative motion between 2 and 3 is possible, that is rotation about one axis which is perpendicular to the plane of the board. So here restraint per pair will be 2. Degrees of freedom is 1 means restraint will be 2. So per pair it is 2. So if there are P1 number of pairs, in that case total restraint will be 2 into P1. So P1 in this case is equals to 1, 2, 3 and 4. So I am writing 4 in place of P1. And what about P2 in this case? That is number of pairs with 2 degrees of freedom. So here there are no such pair which has 2 degrees of freedom. So this P2 in this case will be equals to 0. So in this case, degrees of freedom we are obtaining as F equals to 3 into 3 minus 8 equals to 1. In this way, using Gruebler's criteria, we can calculate degrees of freedom of a mechanism. Thank you.